Now, let's understand how to create the same thing, but instead of using a surface, we're going to use the points coming from a DroneDeploy or from Propeller. What is the advantage of using points? It's because the points will be geolocated, right? So when you export a point cloud from DroneDeploy or from Propeller, you're going to define what is the geolocation coordinate system that you're going to use for that, right? So you would download a file that is going to be an LAS or LAZ file that we need now to simplify that file somewhere, because those points are going to be too much. We can only import up to 10,000 points in cmBuilder. So usually you're going to bring in like 500 thousand, a million points, 10 million points. Like point clouds are very, very heavy, right? And so we need to have a point table that will be geolocated and would be less than 10,000 points.
Yeah, so what we need is a geolocated point table that has less than 10,000 points. And the compatible file formats that we have today is the CSV. And we really, you have to use a template that can be downloaded. When you click on points over here, there is a download template option for you. It's like the template is very simple. Basically, it's just like the headers to let us know like what is an X, what is Y, and what is Z, and that they should be in meters, basically. Okay. So from that point onwards, what are the different sources that you might have from this is mapping platforms that like DroneDeploy, Propeller, or like your surveyor might have that available somehow, and so on and so forth. Sometimes people can create those points from like 3D surfaces in Civil 3D, AutoCAD. There's a bunch of options where you can create those points. And the idea is that the advantage of that is that this is going to be directly geolocated at your site. Okay. So the process is we're going to export those points, we're going to simplify that, import it, and then generate the terrain. Okay, so if your points are coming from a mapping platform like these ones that I already downloaded, we now need to define how we're gonna isolate the terrain from the rest of the points, because when you download this information, it's gonna be exactly what you have over here in terms of in terms of like the points will represent vegetation, buildings, and so on and so forth. So there's this other software that is also free that we use a lot over here that's called CloudCompare. So CloudCompare, you can simply download in your computer. It's very quick to use. And the idea of CloudCompare is that you can import a 3D point cloud, just like this one, by simply, like it will start from scratch over here, by simply clicking on the open option. And then you're going to find your LAZ or LAS file. You hit open. There will be a couple windows over here. I simply just go with apply all. And this window is just showing you that there is a coordinate system applied to that point cloud already. And at this stage, we are gonna, for this session, we're gonna bring those points to a local coordinate system. But when you export it, you will push it back to where it was before. So you just need to hit yes to all over here, and then your point cloud will show up in this software. Okay. So before I start with this software, let's understand what we're going to need to do at this stage. We need to crop the area to focus on the area of our project. We will isolate the terrain from the rest of the points. We will subsample that point cloud to, what is this? It's actually merge point cloud. So let me change this. We need to subsample that point cloud so you have less points. And as an optional like step, you can also merge different point clouds. Okay, so let's start the process in CloudCompare. And over here, the first thing that we need to do is just select that point cloud. And we're going to click on this little scissor over here. So the scissor will allow you to create like a polygon that will define what is going to be cropped out and or left from the final output. So to do that, usually I go into my top view that's over here in the top. And depending on how things are, like sometimes DroneDeploy will create points that are super low over here or super high and not. So you might need to do some cropping looking from the side. But usually I just start with like cropping that looking from above. So we're going to click on the little scissor, and we're going to go ahead and select a polygon that will define the boundaries of our output. You right-click to confirm the polygon, And then over here, you can choose if you want to keep what is inside or keep what is in the outside. Okay. So after that, you just hit confirm. And now you have 2 point clouds over here. So if you deactivate this, you see that that part is gone. And if you deactivate this, that part is gone. So we want to keep this one over here. And now the next step is for us to separate the points from there on the terrain from the points that are above the terrain. So this is a very smart tool that CloudCompare has that's called CSF filter. So if you go over here in plugins, it comes already with the software. You don't need to download this plugin. But if you click on CSF filter, you can go in and there are some parameters over here for you to choose. Usually I just choose a steep slope. I keep my slow processing in advanced parameter setting. I put my cloud resolution to 1. These are the only changes that I do. And what does this process does? It takes it's quite smart actually. It takes your point cloud, put it upside down, and then drops a piece of cloth, a virtual piece of cloth on that. And that virtual piece of cloth is going to touch a lot of points. And those points that it touches will be considered ground points. And the points that are not, that the cloth is not touching is going to be considered off-ground points. So if you imagine that this had like a lot of buildings over here, when you invert that into the piece of cloth, the buildings will be like openings on that. And the piece of cloth only deforms a little bit. So the sides of the buildings and the top part of the building won't be selected, basically. Cool. So now I can choose over here if I want to, if I deactivate the ground points, you see, these are all the parts, all the points that are represented over here that are not on the ground. And if I keep the ground points, these are the points that are on the ground. So it's quite smart. I really like this tool. Cool. And the next step now is for us to select this and see how many points we have left on this point cloud. So my point cloud was exported as a 500,000 points, but after what I did, I'm left with 380,000 points. That's still too much. So we're gonna subsample this to bring into cmBuilder a total of a maximum of 10,000 points. And the way to do that is to click on this subsampling point cloud tool over here. And there are 2 options that I usually use. So one is a spatial, where you define what is the minimum space that you want those points to have. And over here, I would suggest that you use like either 4 or 3 meters, because if you do like in cmBuilder, if you want points to be closer than that, it doesn't necessarily give you like a better resolution, because it's just like a technical limitation that we have. So like you should put like in terms of minimum spacing around like 4 meters and something like that would be already good. But sometimes even when you do that, let's say that I put over here 4 meters and I hit OK, even when you do that, you might not be left with you might still have like more points that you can have. So you might still need to do other types of subsampling, right? In this case over here, this subsampling gave me like almost like 2,000 points. So let's say that I want to keep my resolution a little bit higher than this, and I want to focus on getting like the maximum resolution that I can. So I'm going to go into my subsampling, and I'm going to go into random. And then I'm in the remaining points over here, I'm going to type in that I want to keep 9,000 points. So this will randomly remove points from that surface over there to keep only now 9,000 points. Okay, so these are the three steps that we have. You crop the part, you crop the area, you separate ground from off ground, and then you subsample it to have the limit below 10,000. Javi, do you have a comment?
I was just going to say that in the chat, Eric put a good tip just around if you're using Revit for this, that the environment plugin for Revit has some great tools in modeling and topography. So maybe everyone saw that chat message by Eric, but just wanted to say that specific to Revit, it sounds like there's a plugin there that you could use to get your numbers down as well, just as another option. Thanks for sharing.
That's great, Eric. Thank you. I didn't know about that, and I'll definitely explore it to see if that's a good solution for us to suggest as well. Okay. Yeah, so basically now I'm left with the points that I need, right? So I have like the other thing that I said that it was optional, like about you merging point clouds, that sometimes you are doing this process and your area is too big and you want a specific area to have like a better resolution or something like that, you can crop that area like from before you subsample it. You say, for example, I want like, I don't know, this area over here to have a better resolution. So you crop that area, and then for that area specifically, you keep for that area specifically, you can do a different type of subsampling and so on and so forth, right? So this is an idea that you can choose. Okay. So let's go back to what it was before. So yeah, so like I will, after you do that, if you have like 2 point clouds that have different resolutions, you can select those 2 point clouds and then click on this button over here, and you're gonna merge that point cloud. It will give you this change of color that's called scalar field, but you can go over here in colors and change to RGB. So it will show you like the original colors of those points. So if you zoom out, you're gonna see something a little bit closer to what you had before. Now, the next step is for us to save these points in the format that we're going to use in cmBuilder. So if you select the part that you want, that you're working with, then you click to save. And now you're going to save a task points. So usually over here, I already put like a .csv because we will force this file to be a CSV format instead of any of the other formats that are showing over here. When you hit save, the last thing that you need to do in CloudCompare is to change the separator from from space that will be the default to comma, right? So when you export that, now you have a CSV file to work with. And when I open that CSV file, that is this guy over here. Where is it? Where is it? Where is it? This is what I'm going to get, right? These 3 first columns are what we need. All of the rest is garbage, so we can delete these. And we're going to go and insert a new row over here because I need this template, right? So this is the template that we got that we downloaded from cmBuilder. So I'm just going to copy paste this guy over here. So this X and Y function, it's following the geolocation of each one of those points. So these are actual like the coordinates for those points. And the Z function is just the elevation for that point, right? So when you have this done and you save it, now in cmBuilder, I'm going to go in and import that point cloud. So just starting from scratch again, if I go over here and create terrain from points, then I'm going to need to import that point cloud. And you can only have like a CSV file. Once you upload that file in here, you're going to get like a selection for you to define what this point cloud is going to be referring to. If it's going to be the scene, the scene XYZ definitions, or if you're going to, which georeferencing system you're going to use, right? So the georeferencing system that are available in here, you need to define it at the project level. So when I open that project page, give me a second. Let's go. Project page. There you go. So when I open that project page, I can go into project settings and then go into coordinate settings, and you can see all the georeferencing systems that I can use in this project. So you can add new georeferencing systems over here, and depending on where you're bringing this information from, you see over here my point cloud that I downloaded from DroneDeploy is showing me over here the EPSG code 32616. So you can just type in over here 32616, and that will show. It's not showing because it's already here, basically. So once you add them to this list, they will be available at this stage. So at this stage, I'm going to select that specific UTM coordinate system, and I'm going to hit import. After a while, my points are going to show up at exactly the location that I need them. So this is super, super interesting and easy to do when you have like a geolocated point cloud, because like you don't need to like manually position your GLB files, you defining the elevation for them and things like that. And once you're done with this, you can simply hit confirm, and this will create a new point cloud for you. So I already created one over here, and I can just go into select the DroneDeploy point cloud, and you can see that like this is already defining the shape of my terrain. Cool. There are other things that we can do over here, and there is also the step that I usually suggest. Depending on how your point cloud is, you might have like very open areas without any information about that area, and you need to extrapolate in between. So you can explore different point planning modes as well. Cool. So at this process, we're going to just like limit and 10K points, check your units. So you are always working with meters, define your geolocation point, and then after that result, you can explore different geolocation, different point planning modes to see if you get the best result possible. Okay. So I'm going to set this as my initial terrain, and there you go. So now let me just remove this shape from here. So now my terrain is adjusted. See how like the area that is outside of my point cloud, there is like a big drop over here. So this is the type of thing that once you start changing the point planning modes, you might get like a different result of how the software extrapolates for the parts that it doesn't have any information for. Cool.